Question number 6 of the worksheet on forces in motion. The diagram shows the velocity time graph for a lift moving between floors in a building. The diagram consists of a straight line segment. In the first stage, the lift travels downwards from the ground floor for 5 seconds, coming to rest at the basement after traveling 10 meters. Okay, so in the first stage, the lift travels downwards from the ground floor for 5 seconds, coming to rest at the basement after traveling 10 meters. Okay, so that is this part of the graph. First, the speed is 0, then the lift starts traveling downwards. Now they chose to show that through a downward motion. Okay, so the downward journey is being represented by the region under the x-axis, and the upward journey is being represented by the region above the x-axis. It could have been swapped. So uh, that's how the person who made the question decided to structure it. But they could have made this up and made this down as well. You just need to know that these two parts represent opposite direction of motion. This is in one direction, and in this question, this is downward motion of the lift, and this would be then the upward motion of the lift. Okay. And also, this shows that initially the lift was at rest, then it started to increase its speed. So it's accelerating here. Then it started to slow down and it started to decrease its speed and becoming 0 eventually. So the lift started to move, it accelerated, then it decelerated, and then it stopped. And this is the downward motion, it's going towards the basement. Okay, so this distance would be 10 meters because distance is area under the graph, and we have to find the greatest speed reached during this stage. So we have to find the value of speed over here. Let's call it x. Okay, so if the area is 10, which is the distance, is equals to half times base is 5 units times height is x, which is the speed. So this would be 4 meters per second. So this value here is 4. Okay. For this, the second stage consists of a 10-second wait at the basement. This is the 10-second wait at the basement. In the third stage, the lift travels upwards until it comes to rest at a floor 34.5 meters above the basement. Okay, so this is that upward motion. First, the speed is increasing, 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 and then it stops. The second stage consists of a 10-second wait at the basement. In the third stage, the lift travels upwards until it comes to rest at a floor 34.5 meters above the basement. Okay, so let me just reread that one more time. In the third stage, the lift travels upwards until it comes to rest at a floor 34.5 meter above the basement. Okay, so this lift starts going up, increases its speed, then its speed becomes constant, and then it starts to decrease its speed until the speed becomes 0. And this journey is a 34.5 meter long journey. So the distance covered in this stage is 34.5 meters. Okay. Arriving 24.5 seconds after the start of the first stage. So this is what they're mentioning here. Okay, now what do we need to find? Find the value of V. Okay, so V is this value here. Do we have an acceleration here? Yes, the lift accelerates at 2 meters per second square for the first 3 seconds. So we know the value of acceleration here. It is 2. Acceleration is also the slope in a speed time graph. So I'm going to use the formula of slope. Slope or gradient is equals to rise over run. So the gradient is 2. The rise would be this length, which is V. The run would be this length, which is 3. So the speed is 6 meters per second. This value here would be 6. That is part 2. Part 3 is find the time during the third stage at which the lift is moving at a constant speed. Okay, so now we need to find this time here. Let's call it y. Okay, so again, I'm going to use the formula for area of a trapezium. The area of the trapezium is 34.5, and the formula is half times height of this trapezium is 6, times sum of parallel side. This side is 9.5, and the other side is y. Solve this and you get the required time, which would come out to be 2 seconds. So this is 2 seconds from here till here. Okay, which means that this would be 20 seconds here. Okay, find the deceleration of the lift in the final part of the third stage. So now we need to find the deceleration here. Again, deceleration is again just like acceleration, rise over run. And with deceleration, you don't have to put a negative sign. Okay, so for this pink part, this rise is 6 from here to here. So 6 over the run is 4.5, which gives 6 over 4.5. That gives 1.333 or 4 over 3 meters per second square. Preferably write it as a mixed number, 1 whole 1 by 3 meters per second square.